video, I'll demonstrate DHCP and DNS changed functionality. DHCP no longer supports network access protection. So here in the Server Manager console, I'm going to go to the Tools menu and I'm going to fire up the DHCP Management tool. Where on the left, I'll expand the server and I'll expand IPv4 to expose my IPv4 DHCP scopes. So if I look at the properties of one of those scopes, we no longer have a fourth tab for network access protection, where in the past, we could look at non-compliant devices and we could place them on a different subnet. That's no longer an option with DHCP. There are also a number of changes at the DNS level, the biggest of which is dealing with DNS server policies. What we can do with DNS policies, for example, is set it so that DNS queries from stations on specific subnets might return a different IP address even though they're sending a query to the same DNS server for the same name. Now, we might do this for traffic management reasons, for high availability, or even blacklisting purposes. So what I'm doing here is I'm using a number of commandlets to add DNS server client subnets. Here I'm adding subnet 1 with its IP subnet range, and I'm adding subnet 2 to DNS with its IP subnet range, and then I'm using PowerShell to add scopes. So I'm adding a scope in a DNS zone that already exists called a.local, and the scope here is called subnet 1 scope, and I'm creating subnet 2 scope. Now, the purpose of the scopes that we're creating is that we use those when we build A records to assign them to a scope. For example, when we add a DNS server resource record here in PowerShell to our zone, a.local in this example, we can specify the IPv4 address and we can flag it with a specific scope that we've created previously. So here I'm creating the same record, www, twice in the same zone, but with different IP addresses. Now I'm tying the first one to the subnet 1 scope and the second one to the subnet 2 scope. Then, as I go further down, I add, using PowerShell commandlets, resolution policies to the DNS server, where I determine that the action will be to allow queries for client subnets equal to, so EQ for equals or NE for not equal, in this case subnet 1, and I'm tying that to a scope called subnet1 underscore scope. Clients coming in on subnet 2, now remember, subnets 1 and subnet 2 were defined way up here, where we're giving an actual IP subnet range. So when we define our resolution policies, we link it to those subnets. What we're essentially saying is, for example, if a client's coming in through subnet 2 and issuing a DNS query, then we want to use any A records based on what they're querying that are tied to subnet 2 underscore scope. Now, once this has been done, we can check our work with a number of PowerShell commandlets, because if you go look in the graphical environment, for example, if I were to go to the Tools menu here in Server Manager and pop up the DNS tool, and if I were to take a look at my a.local zone, it would appear that there are no A records. Well, that's true so far, and this is because it's technical preview 2. I suspect that once the product is fully released to market, that will change, but currently, we don't see any DNS A records that we create from PowerShell here that are tied to a scope. Now, if you use PowerShell to build a standard A record not tied to a scope, it will appear here. So right now, we have to do this through PowerShell. Now, we can view our work. Here, I'm going to execute the line here where we can get our DNS server client subnets. So I'll go ahead and click the appropriate button to run that selected code. And we can see that we've got subnets 1 and 2 defined on the DNS server with the appropriate IP ranges. I can also retrieve the DNS server zone scopes I've created. So I'll run that selection. Here I've got the subnet 1 scope and the subnet 2 scope. Now this is where it gets really interesting, because if I use PowerShell to retrieve my DNS server resource records tied to my zone scopes, and if I run that selection, I can see, for example, I've got a www record for 192.168.1.150, but I've also got a second record with the same name but a different IP. Now remember, if you look at the DNS server graphical tool, you're not going to see those A records because they're tied to a scope. And in technical preview 2, that's just the way it is at this point. Now, in the end, what this means is that clients that are connecting, let's say on our first subnet, 192.168.1.something, when they try to ping or connect to www.a.local, it should return only a single IP address. In this case, 192.168.1.150. So let's test this from a Windows 10 client. Here on my Windows 10 station, I'll go ahead and type ipconfig so we can view our current IP address. And we can see that this Windows 10 station is in fact on the 192.168.1 subnet. We can verify that by looking at our subnet mask. And if I do an ipconfig/all, I could verify the DNS server that this client is pointing to. Now, I want to do this because I want to make sure that we're connecting to the DNS server where we've just configured our DNS policies. They're in effect immediately once they're created. So I can see I'm pointing to 192.168.1.150, which is our DNS server. So if I were, for example, to ping www.a.local, it returns the appropriate IP address based on the subnet this client is on. So we now know that our DNS server policies are working correctly. In this video, we learned about DHCP and DNS changed functionality.